So this is a description of our picture. The photo shown a glass prism with one white beam of light shining through one end of the prism and coming out on the other side in a rainbow. The first initial beam of white light does not shine completely straight through the prism, but rather in a bending motion.
White light is made up of many different colors. Color is a certain perception of light. When light enters through a triangular prism, it is refracted at a different angle, which lets out different colors. There are two different types of color models, one being the additive color model, which includes blue, red, and green. And then there's the subtractive color model, which includes cyan, yellow, and magenta. In the additive color model, blue and red make magenta, red and green make yellow, and blue and green make cyan. When blue, red, and green mix together, it makes white. The additive model uses light and filters only. The subtractive color model is like mixing paints. When you mix cyan and magenta, you get blue. Magenta and yellow make red, and yellow and cyan make green. When mixing cyan, magenta, and yellow, you get black.
White light is shining through a glass prism. What is being reflected are the visible additive colors. When white light is refracted, it separates into its component colors. White light is made up of red, green, and blue. Because white light is present, these colors are appealing to the eye through the prism. As a result of red, green, and blue being present, cyan and yellow are shown as well, because cyan is made up of green, blue, and yellow is made up of red and green. Every color in the visible spectrum has a different wavelength. As it passes through the prism, the wavelengths slow down in their path. Objects bring off light, which reflects through the prism, which then refracts different colors of light. A real-life example of this phenomena would be a rainbow.
Rainbows can be observed wherever there are water drops in the air and sunlight shining from behind at a low altitude angle. The most spectacular rainbow displays happen when half the sky is still dark with raining clouds and the observer is at a spot with clear sky in the direction of the sun. The result is a luminous rainbow that contrasts with the darkened background. The light is first refracted, entering the surface of the raindrop, reflected off the back of the raindrop, and again refracted as it leaves the drop. The amount by which light is refracted depends upon its wavelength, and hence its color. This effect is called dispersion. Blue light, shorter wavelength, is refracted at a greater angle than red light, but due to the reflection of light raised from the back of the droplet, the blue light emerges from the droplet at a smaller angle due to the original incident white light ray than the red light. Due to this angle, blue is seen on the inside of the arc of the primary rainbow and red on the outside.